All right, 2.1. We're going to take a look in this section at reasoning and logic. Show of hands real quick. How many of you have had contemporary math? Okay, just a couple of you. There's some overlap between this and what is covered in that class, depending on what they taught when you took it. So we're going to start with what a statement is. A statement is simply a sentence that's either true or false. So an example. Whoops. I ate eggs for breakfast. It is either true or it's false, right? So what would a non-example be? There's a couple of ways we can do a non-example. I'll write one and then I'll verbally give you a couple more. A non-example would be, what did I eat for breakfast? So this is a non-example. It's a question, right? But it's not something to which I can just answer true or false. Right? If somebody says, what did you eat for breakfast? And you said true, they're going to be like, wait a minute, I don't think you heard what I said right? It's not going to work. Another type of sentence that is a non-statement is a command. So if you said, go eat your breakfast, it's not true or false either, right? It doesn't make any sense to say that to it. There's one that's in your group work, I think, when we get to it next time, and it's obscure. And so it's also not a statement. It says something like, he is in town. He who? I can't answer if it's true or false if I don't know who he is, right? But if I say, Ethan is in town, then it makes sense, and we can say true or false. Right? So there's some obscurity kind of things too on that one. A negation is the logical opposite of a statement. So in the negation of a statement, if a statement is written, we'll say P. They like to use P's and Q's for statements. Then the negation of it is actually written with a tilde. So it's tilde P. And the negation of the statement about eggs that I wrote above would simply be, I did not eat eggs for breakfast. The one thing at this point that I want to mention about being careful of with negations is that you don't change the structure of the sentence. For example, I can't remember if it shows up in your group work or homework, but it does show up somewhere where it says something like, all of my classes this semester are hard. Well, you don't change it to do the opposite by changing it to say hard turned into easy. Okay? So we don't want to actually change the structure of the words themselves. We want to insert words like not. Okay? Sometimes there are gray areas. So for example, on that one, you may have classes that aren't hard, but they're also not easy, right? You might categorize them in some other way or something like that. So we just want to be careful on the way that we read, that we change our language, that we use the word not more than anything else. The other thing that we want to be careful of are quantifiers. I just used one a moment ago. Universal quantifiers refer to each and every element in the set. There are words like all, every, no, and none. These are the statements that your parents probably got onto you for saying somewhere along the way where they said, you always, you never, or maybe you said that to them. They're rarely true when we throw those words in there, by the way, correct? But they have these really strong statements that are often difficult for them to be true, even if we want them to. Right? Like I would love to say, I always remember to pray before we have class. That is my goal. But all it takes for that to be false is for you to miss it one day, doesn't it? It does. They're really hard statements. So we'll do an example of one that we'll write down. All boys love their mom. All right, that's universal. Existential quantifiers refer to one or more than one elements in a set. So there are words like some, at least one, and there exists. So this isn't the one I'll write down, but if you take the statement I already made, all boys love their mama, and you take the word all and you make it some, now you've got a statement that's an existential quantifier statement. So existential, that beginning part, X exists, right? You're seeing the exist part of it in there, so the phrasing is similar. So we'll do another one here. Some people like to swim. Okay, so when we do negations with statements that have quantifiers, we have to be careful. The statement about the eggs over here didn't have any quantifier. It didn't say I always eat eggs for breakfast. It just said I ate eggs for breakfast. I ate eggs for breakfast is very simple. We throw the word not in there and we're done when we do a negation. If it's got a universal or an existential quantifier, we have to pay particular attention to how we treat that quantifier. That's your disclaimer here. Creating negations when quantifiers are present takes more care than when they're not. So we're going to do negations for a couple of statements. All dogs go to heaven. Is it a universal or an existential quantifier? Universal. So I'm going to highlight the quantifier. That quantifier has to be treated with care. And here's what we do. You take whatever the quantifier is, in this case, universal, and you turn it into one that's existential. So if it says all, you change it to some. If it says some, you change it to all. Or whatever corresponding, equivalent language makes sense. All right? Because sometimes it doesn't work very well to do that. You'll see an example on part B for that. But this one works pretty well. I'm just going to say some. You could also say at least one. That's fine too. That's another phrasing for it. But we're going to take all, and I'm going to write some. And what happens next is I have to negate the statement. So all dogs go to heaven changes to some. But if I say some dogs go to heaven, that's not negating the first statement, right? It's just a looser statement. So what would I have to do to all dogs go to heaven to make it the opposite? Say it again. Some dogs don't. So some dogs don't go to heaven. Notice what we're not doing. We're not changing the part about heaven. Nobody's talking about going to hell. Nobody's talking about disappearing into non-existence. We're not talking about it in any of those kind of phrasings. We're just taking whatever's there and we're putting a word not into it. So it would encompass anything else that's not that statement. This is not a good statement to do this with exactly, but you know what I'm saying, right? The next one's a little bit better. All right, so the next one says, some of my classes are hard this semester, universal or existential quantifier? Existential, the word some. Okay, there's two ways to change a some statement. I already mentioned it before on one of them. We can do the word all. But if you look back at your universal quantifiers, there's positive universal quantifiers that say like all and every, and then there's negative universal quantifiers that say no or none. Okay? So one way to change this is to say all of my classes. The opposite of that, not the opposite, but the other option of that is to say none of my classes. Those words, all and none, are both universal quantifiers. But they will affect how we write the rest of the statement. If I've changed it into all of my classes, I turned some into all, it made it a stronger statement, right? It didn't change it to be the opposite of. If I change it from some into none, that's opposite, right? I've actually changed it to be like the opposite phrasing of the language, right? So if we do the all of my classes, I still need to make it the opposite sounding statement. So the rest of my statement after here, well, this semester, that needs to be on both of them. I suppose we'll put that in. So if I'm wanting to change the first one, all of my classes this semester, and instead of it saying are hard, what are they going to say? Are not hard. And this is the one I was talking about before, the specific one. You don't change it to are easy, because there are some that might be sort of an in-between. and we don't want to lose that option in the process. We just say are not hard. But if I change it to none of my classes this semester, I don't change it to say are not hard. I already have the negation part of it when I turned it into none. So we would say none of my classes this semester, and it would actually still say are hard, and it would have the same meaning. Both of them are right. They're both logically equivalent. They're correct. But one of them is probably more natural to say than the other one. Which one feels more natural to you? None, right? The none feels more natural on this particular example. Now, sometimes changing it to the all phrasing might feel more natural for the particular example. But this one feels more natural if we do the second one. But they're both correct. All good? Okay. So the next part of this this lesson is going to be truth tables. We'll get started on this, but we won't finish this part of it. So truth tables are used to show all possible true-false patterns for statements. The first truth table I'm going to show you is the most basic one, and it's the one that was relating negations to the original statement. So here's the way that truth tables look. We have columns. However many columns you need. This one actually only needs 2 columns, so I can just split it once. If you put it twice, it's fine. One column in our statement right now is just the original statement, whatever it is, column header. And the other one, because I'm doing a negation truth table, is just the negation of that statement. Absolutely the simplest one we've got. So it goes something like this. If our statement is true, then what do you think its negation is? False. And if our statement is false, then its negation is true. Okay, so that's our first one. It doesn't combine statements. It's just a statement compared to its negation. Compound statements are 2 statements that are joined with the connectives and, or if then. So a connective is one of these words. They connect things together. They connect 2 statements. Statements be connected with the word and. They can be connected with the word or they can be connected with an if at the beginning and a then in the middle, or some variation that means the if-then statement. So the first one we're going to start with is the and statement. Okay? So and statements are called conjunctions. And they are true only when both of the individual statements are true. And statements. So we're going to draw a truth table. It's going to have 3 columns. One column is for P. One column is for Q. And over here where it says written, an and statement is written with an upside down V. Or you can kind of think of it like it's part of an N. Can you see where it being part of an N if the N is a little bit slanted? Kind of thing like that. Or sometimes you can think of it as looking at like part of an A for the word and. That's okay too. So this is an and statement. So in my truth table, that's my 3rd column header. Like that. Okay, so truth tables, I'm going to develop with you all the options of what can happen. So one option with a truth table is that my first 2 statements, both of my statements, I should say, are both true. So individual statement number 1 is true, individual statement number 2 is true. That's one option. Another option is that the first statement is true, but the second one's false. A third option is that the first one is false and the second one is true. And then the last option is that they are both false statements. Okay, so far so good? Now here's the deal. These are the only ways that this can happen, right? There are no other combinations of T's and F's, but then P's and Q's, and there's no other options. So when we're looking at this, what I'd like you to see is the pattern is always going to be the same. It's going to go in the P column, true, true, false, false. And in the Q column, it's going to oscillate, TF, TF. And it's always going to do it like that. Okay? So as we're taking a look at this now, this is an and statement, and to motivate our discussion of when these are true, I want to actually do a couple of statements, and we can actually see that they make sense logically, because this is supposed to be logic. So they better make sense logically or we're going to have a problem. So I'm going to create some statements over here for us to think through. The first statement is going to be, I teach math. And the second statement is going to be, I'm a mom. Okay? So here's what I want you to imagine. We have special guests today, and they're all standing in the hallway. Okay? Can you picture it? There's 4 of them. There's 4 of them out there in the hallway. The first person that comes in is Dr. Marsh. So many of you know Dr. Marsh. And Dr. Marsh comes in and she says, I teach math, and I'm a mom. Does Dr. Marsh teach math? Those of you who know her? Yes. Is Dr. Marsh a mom? Yes, she is. That's why she's my first row. So if she comes in and she says, I teach math, I am a mom, that would be a true statement. Because each of them individually are true by just the way we do English, and other things, we would all agree, yes, that's a true statement. She's not lying. Okay? Do you guys know Dr. Tucker? Some of you do. Okay. So for those of you who know Dr. Tucker, she's candidate number 2 in the hallway that's coming in, right? She's our second special guest. Candidate number 2, Dr. Tucker comes in and she says, I teach math and I'm a mom. Does Dr. Tucker teach math, for those of you who know her? She does. Is she a mom? Do you know? She's not. She's not a mom. She has no children. So if she comes in and she says, I teach math and I'm a mom, you're going to be like, show me those kids. I don't know you had any kids, right? She didn't have any children. So this would be a false statement. Okay, we'll do Dr. Justice next. Y'all know Dr. Justice, right? Okay, good. So Dr. Justice comes in, and Dr. Justice says, I teach math and I'm a mom. Does Dr. Justice teach math? Nope, she does not. She teaches special education and some of the gen ed courses for education. And is she a mom? She is. She has children. They're grown, but she has children. In fact, I've had one of her children through this class, in fact. So she comes in and she says this, the first statement, teaching math is false. The second statement about being a mom is true. But that makes it a completely false statement overall because one component of it was false. Yeah. Okay. I usually do the last one as Dr. Thomas. Dr. Thomas is the president of the university. Y'all know who I'm talking about now? Okay, good. So Dr. Thomas comes in. He says, I teach math and I'm a mom. You're going to be like, excuse me? He does not teach math. He is not a mom. And after you giggled a little bit at him, just like you did at me, you would also write down, oops, I'm sorry, I wrote it wrong, that this is a false statement. It's a false statement. It doesn't make any sense, right? He wouldn't come in and he wouldn't say that because it's weird. Yeah, it doesn't work. Okay, so first so good? Okay, we're going to use our same people in the hallway here for our next one. So these are conjunctions. They're and statements. The next one is a disjunction. So disjunctions are or statements. Or statements are true if either one statement or the other statement or both are true. If our statements are P and Q, like they were before, this is written as a V. Okay? It's an or statement. So we have the same options over here, true, true, false, false, true, false, true, false that we had before. All those are the same. And we're going to use the same example that we did before. I teach math, I'm a mom. And our same people are going to come in. Who is our first one? Do you remember? Dr. Marsh. Dr. Marsh comes in and she says, I teach math or I'm a mom. And it sounds funny, right? In fact, you probably would be like, I thought she was both. If you know her, right? You would probably think that. She is both. But the or statement in between doesn't make it false. It just makes it sound a little bit funny with our grammar. Okay? So this is a true statement, even with the or between them. Our next one that came in would have been Dr. Tucker. Dr. Tucker comes in and she says, I teach math or I'm a mom. And you're like, okay, well, I know she teaches math. Yeah, that one works. So it's a true statement because one piece of it's true. Dr. Justice was next. Dr. Justice comes in and she says, I teach math or I'm a mom. And you're like, again, well, she's a mom. So that's a true statement. And Dr. Thomas comes in and says, I teach math or I'm a mom. And you're like, still no, not working for me, right? It is a false statement. So every single time, it will work out this way. My examples just to motivate us to think that they make sense. But they always do work this way because the definition said so. These are defined quantities. We are defining or statements to be true if one or both are true. We are defining and statements to be true only when both statements are true to begin with. So and statements produce a lot of false outcomes, don't they? Right? They only have one true outcome. And or statements produce a lot of true outcomes. It only has one false outcome. The thing that's important to note, and this will be true about the next one we do as well, is that in both of these scenarios, if the statements are both true, the result's going to be true. It doesn't matter if it's an and, it doesn't matter if it's an or. Okay? And we'll do one more piece before we stop. We'll do our truth table right here, and that'll be a good spot for us to stop. So we're going to create a truth table. It doesn't have any context on this one. We'll get some context stuff next time. But in our truth table, it has a column for P, and it has a column for Q. We're always going to have a PQ column. So even if you get stuck, you can always start. The P column will always be what it's been on the other two examples, true, true, false, false. And the Q column will always be true, false, true, false. Again, they're always going to look like that. However, there's two more columns that this truth table is going to need. There's an and in it, right? You have the upside down V thing going on. So we're going to have that. But I can't just put that in there yet. I'm doing an and statement with P. I've got a column for P and tilde Q, but I don't have a column right now for tilde Q. So the next thing that I need is I need a column for tilde Q. Because that's what I'm supposed to be joining here in a minute. And our last column would be the P and tilde Q column. Okay, we did negations, or at least we talked about them before. The negation is going to be the logical opposite of whichever one it's the negation of. This is Q. I want the negation of Q. So I go back to column Q and I reverse everything. Column Q said true, false, true, false. You're right. Katie's right. So it's going to be false, true, false, true. So negation columns are very straightforward. There's really not a lot that goes into having to actually process that. But we have to be careful when we get to the and column. Number one, to make sure that we're considering the right columns. So I'm going to highlight mine. I'm considering column P and column tilde Q. Don't get off on the column line, because if you do, you're probably going to make some mistakes, right? And it's an and statement. When is an and statement true? If both are true, and that's the only time, right? So on the first row, I have true in the P column and false in the tilde Q column. So true, false is false. Row 2, I have true, true. That one's true. Row 3, I have false, true. That's false. And row 4, I have false. I said false, true. It's false, false. I'm sorry. It's still false. Row 3 is false, false. It's false. Row 4 is false, true. And that one's also false. There we go. Okay? So it's a matter of processing the pieces. And we'll pick up there next time.